Hey everybody, welcome to my channel. In this video we gonna be answering the question, why does an LED need a resistor? And just in case you're not an electrical engineer, I am gonna give you the simplest explanation possible so that you can understand it no matter your background. So let's get into it. First of all, why is this even a question? Well, because I get asked this question all the time in the comment section under my videos, or whenever I upload a video about LED. I get the exact same comment over and over again asking me, why do LEDs need a current limiting resistor in series with them? Look, I literally uploaded a video last week showing how to make an LED clock, and in the comment section there were tons of people asking me, why do LEDs need a resistor? So I decided I needed to make a video specifically dedicated to answering this question once and for all. Okay, so let's answer the question, why does an LED need a resistor? Well, it's because if you don't put a resistor in series with an LED, it will burn up and die. Okay, that's kind of a complicated way of putting it. Let's try to simplify this a little bit more. Now here is a little secret. It's actually really hard to give a simple explanation to some things that are actually really simple. Like when you trying to explain something really simple to someone who doesn't know anything about the topic, and they have all sorts of questions, which seem very valid to them. But to you, they're kind of stupid, because they don't understand the basics. So basically what I am saying is, sometimes it's hard to keep things simple when explaining something, but I am gonna try my best in this video. Okay, so first off, let's talk about what an LED is. Now obviously, an LED is a light-emitting diode. Well, a diode is essentially a one-way valve for electricity. In other words, it only allows electricity to flow through it in one direction. Just like a regular old-fashioned light bulb. If you put batteries in backwards, nothing will happen. See, same thing with an LED. If you put batteries in backwards, nothing will happen. You might notice though that the batteries are labeled plus and minus, and the reason for that is because inside of the battery there is a positive terminal and a negative terminal. The positive terminal is where the positive electrons start their journey from. They come from the negative terminal and they travel through the circuit doing stuff. And then when they have nowhere else to go, they return back to the negative terminal. And so what happens inside of an LED is that if you put the positive side of the battery towards the positive side of the LED, the electrons will flow through the LED and out the other side. However, if you reverse the polarity, nothing happens. Now, since an LED is essentially a one-way valve for electricity, it means that if you hook up a battery directly to an LED without any other components in the circuit, all the electricity will flow through the LED. And you may think, well, hey, that's great. Isn't that exactly what we want? We want all the electricity to go through the LED, so it lights up, right? Well, yes, ideally we would want all the electricity to go through the LED, but not too much electricity. That's the problem. You see, an LED is designed to operate within a certain range of voltage and current. Each LED has a datasheet that tells you the maximum amount of voltage and current that should be applied to it. And if you exceed those limits, you burn up the LED. And so if you connect a battery directly to an LED, you re-providing all of the electricity to go through the LED and their S. Nothing to prevent that from happening. So that's why you need a current limiting resistor in series with the LED. The resistor will drop the voltage down to whatever the LED needs, and the rest of the voltage will be dropped across the resistor itself, Q. Now hopefully you can understand that by placing a resistor in series with the LED, we can limit the amount of current going through the LED. Okay, now I've got a few more examples I want to show you guys. For example, this is a 5-volt LED. The label on the LED itself says 5 volts. And so this LED needs 5 volts in order to operate. Now if I hook up a 9-volt battery to this LED, the LED will still work, but it will be brighter than normal. Now, this isn't necessarily bad, but if you're hooking up a bunch of these LEDs together, you want each one of them to be super bright because they'll end up burning up. Again, the solution is to add a resistor in series with the LED to drop the voltage down to 5 volts. Now if I hook up a 3-volt battery to this LED, the LED will dim quite a bit. And this isn't good either because you don't want your LEDs to be super dim. The solution again is to use a resistor in series with the LED to bring the voltage up to 5 volts. Now I hope you can see that in both of these cases. The resistor helps regulate the voltage and therefore regulates the current going through the LED. And that's really all you need to remember. If you're going to be hooking up a bunch of LEDs in your projects, you need a resistor in series with each LED to regulate the amount of current going through it. Otherwise, you run the risk of burning up your LED. Now, I also want to mention another point. When you hook up a resistor in series with an LED, the resistor will drop some voltage. That voltage drop will depend on the value of the resistor and the amount of current going through it. The resistor will always drop some voltage no matter what. But if you choose a resistor large enough, the voltage drop will be minimal. Another thing to consider is that when you're hooking up an LED, it's important to take into consideration the forward voltage drop of the LED. Every LED has a different forward voltage drop. For example, this 5-volt LED drops 2 volts, and this green LED drops 3.3 volts. So when calculating the resistor value, you need to take into consideration the forward voltage drop of the LED. So hopefully after watching this video you can now answer the question, why does an LED need a resistor? The simplest explanation is because it regulates the current going through the LED. If you don't regulate the current going through the LED, it will burn up and die. I just want to say thank you guys so much for watching this video. I hope you learned something new. If you did, make sure to give me a thumbs up to let me know that you approve of this video. And don't forget to subscribe so you can be notified whenever I upload new videos. I upload new videos every single week. Also feel free to follow me on social media. I post updates whenever I have free time. I also post pictures of my dog because he's really freaking cute. So yeah, feel free to go check that out. And so yeah, thank you guys so much for watching this video. I hope you have a wonderful day. Goodbye.